Okay, we have Chapter 6 review exercises, question E49, and I try to avoid questions that involve a lot of calculations. However, this one is pretty interesting. If you've wondered how the bumping system actually works and why do airplanes overbook, this gives a pretty good illustration of why it might be a good idea for them. So I'm going to create a chart here in Excel that's going to make this much simpler. And I'm just going to start with 120. I realize it's less than or equal to 120, but that one's really not going to matter anyway. And I go up to the down arrow, which is the series. And this time I'm going to step every time by 10. In other words, I want, actually I don't, not yet, sorry, step by 1 here. And I'm just going to delete off these that don't matter. And then this payout, so if 120 or less showed up for a flight that has 120 seats, the airline wouldn't have to pay any in this voucher system. If there was one extra person, they would have to pay $100, and so on. And two extra, they'd have to pay $200. Here's where I'm going to do a step value. I want it to go up every time by 100. So if there were actually all 130 people who booked the flight showed up, we'd have 10 vouchers that we would need to give out, so we would expect to pay $1,000. But the question is, how likely is each of these situations? So here's where I'm going to use the binomial distribution. I'm going to start here because remember this is everything between 0 and 120, so it's a little more complicated. I can do it, but let's start with 121 here. So I'm going to do equals binom, and as soon as I hit that in, I'm seeing my options to get the .dist, binomial distribution, the number of successes. So in other words, the number of people who showed up. I'm going to grab that over there. Number of total trials, 130 are the total people who booked the flight. And the probability that each one will show up is 0.9. That's given to us because we have a 10% no-show rate, which means each person has a probability of showing up with 0.9%. And cumulative, no, we do not want the cumulative. We want to get the exact for each of these. Okay, now up here, let me just drag this one up. In this formula, we do actually want the cumulative because that's all the way up from 0 to 120. So this is the chance that we won't have to give out any vouchers, and then so on. Now, how much will we have to pay out? Well, that depends. It's the probability of that situation happening times how much we have to pay out if that situation actually does happen. So notice we wouldn't have to pay anything, even though this is the most likely situation. Now here, there's a 6% chance that there's going to be 121 show up that we have to give one voucher. So since there's a 6% chance, a $100 payout, that's an expected value of $6. So we can go through here and fill out the numbers in the chart are the ones coming from this. And as always, when we have these E's, we can stretch that column. Whoops, didn't get it large enough. Okay. Yeah, maybe I can't. So I would need to go in and change the settings. So I'd highlight those and right click if I did want to see those more clearly like these others are shown up. On average, how much will the airline pay out per flight if it sells 130 tickets? Okay, so if it sells 130 tickets, well, that's the entire scenario we're working with. We just need this total expected payout here. So let's sum that column. Let's do equals sum. Highlight all these cells. And that gives us $31.80 right there. So $31.80, not bad, especially if we're getting all of the money from 10 extra tickets. The airline would certainly make quite a bit of money. Even if these payouts are more, which they usually are, usually a couple hundred on a domestic, maybe 400 or 500 on an international, even with that, the expected payout is going to be much less than the extra amount of money they make by selling these 10 overbooked tickets.